Okay, so what good are logarithmic and exponential functions? What are they for? Well, let's take a look at Transformers, the movie from several years ago. And its first several, well, actually quite a few weekends that it came out, the actual revenue that it made, the box office revenues. If you look at a table of these values, you can see they start up very high, and then the next week it's less than half, and then, oh, not quite half. Anyway, the box office revenues are shrinking, and quite rapidly after that first weekend. And that's pretty typical with most movies. A lot of people want to see them right away, and then the attendance kind of dribbles off after that. Well, you can actually fit an exponential function to these box office revenues. You can actually model this decrease with an exponential decay function that works pretty well to help you predict the revenue the movie might make in, say, the 12th week or the 15th week or a half a year from when it comes out. And the exponential function, if you look on the next page, the exponential function that fits this table quite well is y equals 120 times e to the negative 0.5354 times x. Now, here's what the variables mean in the function. X stands for the weekend number that the movie is showing, and y is going to give you the money made in millions. And you can actually graph this function. You can see how rapidly the attendance and the dollar amounts decrease over a number of weekends. But what we can do then is we can see how closely does this function actually fit the table on the other page. So pick up your calculator. What we're going to do is we're going to do the function of x equals 3 for the third weekend, and then x equals 6 for the 6th weekend, x equals 10 for the 10th weekend, and then we're going to predict how much money it would make in the 12th weekend. So here's what we do. This is called just plug and chug. We rewrite the formula. Y equals 120 times e, remember that's that funny number, 2.72 something, to the negative 0.5354, and we're going to put in 3. We're going to put in 3 for the third weekend. So in parentheses, I'm going to put a 3 here. So how do we do that in our calculator? We're trying to find out how many dollars it makes in the third weekend according to this function. Okay, so put our calculator on. Let's type in the 120, and then just to be safe, let's write times, just in case your calculator needs it. Mine shouldn't, but I'm going to put in there anyway. Times E. Remember where your E key is? Mine is opposite my LN key. And you should see e to the and a pair of parentheses to put in an exponent. And in this case, our exponent is going to be a product. It's going to be negative 0.5354 times, so that I need to keep this all inside those parentheses, times weekend 3. Close my parentheses, and I get about 24.0, let's round to the nearest 100th, 24.08. Oh, no, maybe let's round to the nearest thousands. 24.078. 078. And this is in millions of dollars. Okay? Alright, now if I go back to the chart on the previous page, let's remember this number, about $24 million. And I go to weekend 3. It is indeed around $24 million. So that's a pretty good model so far. It's actually predicted the week 3 earnings pretty closely. Let's try it now with the weekend 6 earnings. So if you have a calculator that you can just go back to your function, like I do, I'm going to just arrow over until I find that 3 that I had typed in, and I'm going to change it to a 6. If you don't have that ability on your calculator, you'll need to type this in again. But instead of putting a 3 here, you're going to put a 6 here. 120, press your E key, and inside the parentheses put negative 0.5354 times 6 this time, and then close your parentheses. Alright, so I've already got it in here. And I get about 4 so this is week 6. I'm going to write down what we did. We did 120 times e to the negative 0.5354 times 6. and I got approximately 4.831 millions of dollars. Okay, let's go back to our chart now, the previous page. Let's see how well it predicted weekend 6. Not bad, not bad. They are going with about 4.7 million. We got about 4.8 million. Pretty close model. Let's try weekend 10 now. So again, we're doing y equals 120 times e to the negative 0.5354. We're putting a 10 in this time for our exponent. And again, I'm going to be lazy. I'm going to go back to where I already have the function in my calculator. Now, this could be a little tricky though because 10 has 2 digits, but let's see. Let's type it over and then close the parentheses. Alright, and I'm getting about 0.568 millions of dollars. Alright, and let's check that with the table. For week 10, 0.568, 0.576, not bad, not bad. So I feel okay about using this exponential model, this equation, to predict week 12. So let's do that. Let's do it over here. Y equals 120 e to the negative 0.5354 times 12. Kind of ran out of room there. Times 12. And again, I'm going to be lazy. It's already in my calculator. Let's go find it. I'm going to type over my 10 and make it a 12 for 12. Close my parentheses, and I get about $0.195 million. Okay, so about $195,000 in week 12. And I guess that would seem reasonable since this weekend it was about $575,000. The next weekend it would be maybe half that or less, and so on and so forth. So exponential functions are really cool because you can model real-world things with them and make predictions.